And Jakob, you have the first one this morning.
Yes, I put a very nerdy topic on the agenda. There was a discussion in our Slack channel last week where, in the context of error budgets, where Bob pasted a PromQL formula and said, how do I say what this is calculating? And he was probably trying to answer the question from somebody who wanted to understand error budgets. And I didn't understand at all. And I started to get worried that we were doing something very fishy in our calculations. And then Bob kindly created an issue. And then I thought, okay, now I have to sit down and look at the issue because I created a problem. And then I thought about it some more. And then I realized what we're doing is not fishy. If you, or I was able to explain to myself what it is we're doing and why it's right. And that's what I want to talk about now. And I should share my screen to make this less abstract. So I'm just going to double check my browser here.
I might even be able to find my mathematics textbook from university. It was the last time I thought about these things.
Well, Andrew, you're probably the one person who is most comfortable with this calculation because I think you worked.
Yeah,
I suspect you're the one who put it in there.
Thought of Riemann sums when I put it together, but maybe there was a subconscious.
No, probably not. Yeah, so the topic I put on the agenda is Riemann sums, and that's a very, very nerdy because Riemann is a 19th century German mathematician. But the nice thing is that if you Google Riemann sum, then you get a Wikipedia page with nice pictures that help to understand what we're doing. So I think I have an excuse for it being so nerdy and calling it the Riemann sum because it guides you to a picture. But first I want to show what the question was about. So the formula was sum over time, failure rates 1 hour, 28 days. This formula. Well, actually this one, bigger letters. So what does that mean? And the answer is too complicated. So the answer is, it is the number of failures in the past 28 days divided by 60, assuming that our recording rules create a rate metric every 60 seconds. If it was every 5 minutes, that would be 300 seconds, and it would be divided by 300.
I'm so glad you've done this.
So the divided by 60 makes everything complicated. But so let me try and work back and explain what we're trying to do. What we want is the number of failures in the past 28 days, because this is the sort of number we care about for error budgets. We want to see an increase over a long range. And the data we have are rates. And a rate is an instantaneous, like how much things were increasing at a point in time, but it doesn't tell you immediately how much increase you had over a window of time. And what you need to do if you want to go from a rate to the actual increase is to take the area under the graph. I don't know if this makes sense, but and that's what integrals are in mathematics. Just again, very nerdy. An integral is taking a graph and computing the area under the graph. So that's where these pictures come in. And if you want to approximate this, then one way of doing it is to draw these little rectangular boxes under your graph at different points and calculate the area of each of these boxes and sum those. And then you have an approximation of the area under your graph. Now, what we're doing in our formula is, so this line would be failure rate 1 hour. And these dots are where we have values. And what I'm assuming is that the time between these dots is always the same. It's always 1 minute. So if these are our failure rates, then it would be the rate here times 60 for 60 seconds, and the rate here times 60, the rate here times 60. Well, they drew it on the other side, but let's ignore that for a moment. And you constantly do rate times 60 plus rate times 60 plus rate times 60 plus. Does that make sense? Now, if you think of multiplication and addition, if you have lots of pluses and every time you do times 60, then you can also first sum up the things and multiply by 60 once at the end. That is called distributivity. So because we're assuming that all these things are evenly spaced, it's always times 60. So you can also say it's 60 times the sum of the rates. And that is then the area under the graph. And so that's one. And then why don't we write 60 times sum over time failure rates? Because we take these increases, but we always divide by another increase. So the 60 is both above and below the dividing line. It's in the numerator and in the denominator, so it disappears. So we don't need to write 60 every time. And it's also nice because 60 is a configuration value. And as long as all these rate numbers are generated with the same configuration value, now we don't have to write the configuration value in our Prometheus formula.
Can I just, this is so awesome that because this is all in my head when I was doing it and I didn't express it very well. But the one, just on that point, the one thing that made me feel confident about canceling out the 60 on the top and the bottom, because that's how I thought about it. I was like 60 on the top and 60 on the bottom, was that both of those configurations are in the same recording rule group. So, and that was like, they always will run paired together. So if we change it so that they're running at 30 or whatever, there will always be pairs of them. So the failure rate and the total rate will always be increasing. So even if over the period it was changing, it wouldn't matter because it's changing at the same rate. So
at the same time.
Yeah.
So and I think so. One of the reasons. So the other thing I was curious about was my first thought when I saw this expression was, why do we have a thing here that depends on the recording rate, the rate at which we generate data points, like the calculation should depend on it. So the assumption is that we only write sum over time of a rate in an expression where we know that all these rates come from the same recording group and have the same interval, because then all the interval size cancels out and is irrelevant. And if somebody would throw an arbitrary PromQL query on the wall and they do sum over time of a rate, then you can't quite be sure what you're getting. But because of the extra assumption that you just pointed out, Andrew, that it's all from the same recording rule group, it makes sense. And that assumption is part of explaining what this formula means.
There was a time where I had a second expression, which was the number of samples or the number of observations that we had over that period on the top and the bottom. But then I realized that kind of messes things up. We didn't need it. Firstly, we could cancel it out. It made the query slower. And it just worked more elegantly if we just cancel it out on the top. So you can say over a 28-day period we saw whatever 14,000 or whatever, however many samples, and therefore we can kind of infer from that we're doing this once every 60 seconds. We can go back from the number of samples. But it worked out that we didn't need to do that. The other thing that's slightly different from a Riemann, I'm fixing my pronunciation as I say it, is that there is overlap. So in that Wikipedia page that you showed, each of the bars is taking up a. So do you want to just share your screen that you had open a second ago? So those bars are kind of each kind of distinctly taking up a piece of the x-axis. But actually, if you just go back to the ratio calculation, the last tab here, you'll see here that we are using a 1 hour rate over a I wasn't sure if that was right, and I actually think I said in a call. Luckily, we have someone who's very good at maths here in a demo call, but because I was
not
you weren't
sure about it.
Yeah, I was actually, but the thing about it is that through experimentation, because I didn't go through the whole sort of approach, like the mathematical approach to proving it was correct, but I did lots of experimentation on it on lots of different series, and it seems to work. This is also what we do the upscaling with on the Sidekick metrics.
Yeah, and I actually I didn't make progress on understanding this formula until I started ignoring the 1 hour, because I think the 1 hour is important because well, the way I think of the 1 hour, and this is not really okay. Mathematical me doesn't like it because it's too hand wavy, but for everybody else, it's probably fine. I think the 1 hour is doing smoothing, and if the window is very small, then we would have very erratic rates, and there would be much more. They would be much more jumpy. But we make the assumption implicitly that the rate stays more or less the same for 60 seconds. And if your rate is very jumpy, and so if it's like if something very local happened that was off, and you get an incorrect rate, and then you multiply by 60 seconds, then you're multiplying that inaccuracy. So you want a relatively smooth. Well, okay, the way the mathematics work is that you calculate the rate with an infinitely small window, but you also do the sums with an infinitely small width. And then if you're lucky and you use the right, then usually it works out. But that's not the world we're in. And so intuitively, I think these rates need to be smooth. And that's why 1 hour makes sense. But apart from that, they need to be smooth. I don't think they really change what the expression means. Like you can just think this is the rate. Like
they're just a way to get a point on the graph. That those points on the graph that you're saying.
Exactly.
I mean, how many of those you've got affects you of sort of the fidelity, but not the maths of whether it works.
Yeah. So you need to get points on the graph somehow. So you need some window, and 1 hour is a valid choice that through experimentation Andrew discovered works well. But if you want to try and work out what the 1 hour means for the approximation of the increase, then I think the math would get very complicated, and I just don't want to do it.
Yeah, and I was also worried about the jitter because the evaluations are not happening exactly they're not back to back 60 seconds. So there's always going to be sort of because Prometheus is kind of going in this loop, and it's got a schedule, and every 60 seconds ish it will run that recording rule, but it's not exactly 60 seconds, right? Like depending on what the server's doing. And so there was also kind of some concern around that. There's another reason why I think this is actually quite an important discussion to have, and that is around the 3-day rates, because I think we want the 3-day rates. Especially
for alerting purposes.
And especially for the sidekick, for the low frequency sidekick jobs. And so we want the 3-day rates. We can't really practically evaluate the sidekick pods over 3 days because we'll just melt Thanos and sidekick down into
that's the other part of the story, that if you want to know the increase and you had all the Prometheus data, then you could just write a Prometheus query that takes 28 days worth of counter values and calculates an increase for you, but that melts Prometheus, and that's why we have these rates which are lower in number.
Yeah, and actually in the days that we were in VMs, we could pretty much get away with it. It would be a slow query. But now with the number of pods and the pods starting and stopping like every 2 minutes, we can't really, there's just too many series now, and it's actually got a lot worse. So with the 3-day one, I think what we're going to do is for everything. So not just for Sidekick, but for the web and for API, all the 3-day ones will be constructed from lower sample rates, and then kind of I think in the code base we call it upscaling. But this is where having you looking at this is super fortuitous right now, because what I found when I did it with Sidekick is it worked, within, I remember I put a graph on, and I think Bob reviewed it, and maybe Craig Furman, and you could kind of see that it kind of tracked the real data. It wasn't perfect, but it was kind of a rounded version of the real data. But then for some, if I remember correctly, for some things like for API or something, there were certain conditions where it didn't work very well at all. And I think what it was, again, this is kind of scratching at the back of my mind.
Specifically the 3-day rates.
No, I think what it was that when the failure rate doesn't, for certain sidekick, certain things, when there's no error, there's no observation. So if you don't have any 500s, then that series is absent. It's not 0, and that for certain things, that was a real big problem. And that's one of the reasons why I changed the recording rule to always give us a 0. And so I'll need to reevaluate that now and see if that's been fixed.
Right. I was actually wondering about this too. And it looked to me like if you assume that you have a constant trickle of data points with 1 minute in between, and if some are missing and you take the sum, then I think you're effectively treating it as if the rate is 0. Because if the rate was 0, then they also contribute nothing to the sum. And if they're missing, they contribute nothing to the sum.
Yeah.
So it's indistinguishable from rate 0, I expect.
There was like, I was looking at because where this conversation really started off was with Ben, and Ben looking at the Prometheus servers melting down, running these 6-hour queries and saying, why can't we just use average over time? And me saying, no, average over time really doesn't work. Like, look, here's the observed data and here's what happens with average over time. And, this doesn't match up. And then kind of figuring out the theory from the practice. But then with this approach, I looked at it and I said, this is a better approach for kind of estimating what the 6-hour rate is. And for Sidekick, at the time, for Sidekick, it worked really well, but not for everything. And that's why in the metrics catalog, we have a switch that says, like, I think it's called like upscale longer rate queries or something like that. It's upscale longer something. And it's only enabled for Sidekick and for Postgres, because those are the two that we have. For Postgres, we're using all the Rails metrics and then putting them together. And I need to still figure out why we can't just apply that generally, because for some of them it was like out by a few percent.
I'm curious too, so maybe we can look at that sometime.
Yeah, because and if we want to do the 3-day one, because I don't think there's any metrics where we can just do 3 days using the raw data. It's going to be too expensive. And so we have to fix this for the general case in order to use it for the 3-day one. So it's something to think about.
Yeah, no, maybe we should just sit down and you talk me through.
I'll take a look and see if it's still the case. Like, I need to kind of boot it all up a bit. I've forgotten some of it, but I need to take a look, and it's quite easy to check. It can be a bit slow, but I'm doing it the experimental sort of engineering way. Try something, try again until it matches.
Which is great, of course. Yeah, I guess my message, if I could try to summarize it, is that summing rates is okay as long as you know that the recording rate is a constant time in between, more or less constant. It's never going to be perfectly constant. And also, if you're dividing, if both the numerator and denominator all use this same recording rate, then it works out, because then you have then time 60 disappears everywhere. That was my message.
I think it even might have been in one of maybe in the upscaling MR, it was kind of mentioned, but it felt to me it was like okay, approved, and I never had it properly validated. So I'm really, really happy that it's been properly validated now, and somewhat surprised that it actually works.
I'm not, well, yeah, you shouldn't be surprised that it works, because we're using it, right?
Yeah.
We told a lot of people to trust these numbers.
I'm pleasantly surprised.
Yeah. I also wanted to share this because I think all of us are sort of ambassadors for error budgets and these metrics. So I don't expect I hope nobody will mention Riemann sums outside of this call, because it would be probably would alienate the next person. But I wanted to share this to have more intuitive understanding of what these numbers are, to somehow boost that for everyone. So thanks.
The one last thing before we move on, I kind of toyed with you, because average over time is equivalent, isn't it?
No.
On both the top and the bottom.
No, with average over time, the number of samples is part of the calculation, and the number of samples in the top might be different from the number of samples in the bottom.
Oh yeah, that's why. Yeah. And I think that's, okay, cool. Yeah, I think that's why it's elected away. I can't remember now, but I looked at
I also remember that you were talking about figuring out how to get the calculation right when you're mixing errors over time, like error increase and latency miss increase. And you have these different kinds of data, and you basically need to do a weighted sum. You can do that with the averages, or you don't know the weights. And the moment you work with increases, you effectively get the weighted sum, but you don't have to figure out what the number of samples was, because who cares what the number of samples was if you can calculate
if
the
you
number.
know that they paired.
Yeah.
But it actually may be something we should document somewhere, because there's probably some point in future where people say, oh, well, maybe we don't need these two things to be evaluated together. And it's kind of a side effect
that
of
was my starting point. Like Bob showed me this formula, and I thought, why on earth are we not doing average over time? And do we have a formula that makes assumptions about a Prometheus config or a Thanos config? Like, can't we do it without those assumptions? And so, no, we need the assumptions, but yeah, we should document them. Well, thanks for listening to all this. There's nothing else on the agenda. I don't want to keep droning on.
Is there anything that anyone else would like to demo?
I've got a couple of things I wouldn't mind talking about.
Go for it.
It's actually in the same vein. It's what we were talking about last week, the metrics and initializing the metrics from Sidekick. Which ones were there? Sorry, not prepared. Initializing a metric for every Sidekick job that could run on a cluster, rather than waiting until they run because of these low rate Sidekick jobs. And basically, it goes from about 10,000 metrics at the moment to about 40,000, which is not really good, but it's also not out of scope with others. I was just wondering if anyone had any other thoughts on that. Does it fit?
Well, it goes on a Prometheus server. Like, does that thing have enough RAM to do that?
I would assume so. Is it all on RAM?
There's some fairly well publicized documentation on sizing, the number of series it's in the Prom.io docs, but the kind of simplest approach would be to look. I suspect that Prometheus DB is probably under more duress, and so to look at where we are, just relatively look at the default DB and app instances, and see if it's down.
What instance do these 30,000 extra data points land on?
They will be on the app instance here, which is probably one of the stressed ones. Well, other than DB, there's a metric for the number of metrics, isn't there?
Oh, it's not actually the app. I take that back. It should be on the GKE one now, isn't it? Prometheus-GKE.
That's a very good. Well, some of it, except for the sidekicks that run on VMs.
How many sidekicks run on VMs still? 7
of them, until we get the 1 queue per shard. Just the last of the catch-all, which we desperately wanted to turn down. So we could ignore those. Actually, and they're not the problem, because there's only 7 of them. They're the tiny bit. It's the GK. So you're right, it's GKE. Is there a metric for the number of metrics on a Prometheus?
It's actually under, if you go to Prometheus-GKE, I'll just share my screen quick. So Prometheus-GKE, and here we have, big surprise. Almost all of our top 10 are sidekick things. So they have under the status thing over here, they have like a bunch of things. Top 10 label names with high memory usage. Path. That's not what I would have expected.
Right, and so there's 1.9 million, almost 2 million in series, and I'm proposing to add 30,000. So less than 1%. That seems reasonable.
If we go look at Prometheus app, let's go to that same TSDB status. The number of series, what's that? 2 million. Okay, so it's actually a lot higher, and then just one more, just for a bit of. We could probably find a metric.
Were you saying GKE is at 5 million?
Oh, 5
GKE is at 5. And that's almost certainly because of the pod load, because of
Yeah.
the
Other pods creating new series when they go in
Yeah.
and out of existence.
So, wow, okay. So my guesstimates were totally off. So Prometheus DB is only at 500,000. So it's cruising. Prometheus app is at 2 million. Prometheus GK is at 5 million.
So adding 30,000 is neither here nor there.
Yeah, it's a drop in the ocean.
Yeah, the other argument, well, it's not really, doesn't really mean it's safe, but we already defined them. It's just that they don't, theoretically they could have
Yeah.
happened already.
Yes. Yes.
And some of them have, just
Yeah.
not all of them. Yeah.
Yeah. In practice,
But
it's somewhere between 10,000 and 40,000, just most of the time at the lower end because we're lucky.
Yeah. But just because they could have happened doesn't mean that we know they're not happening, because otherwise we wouldn't have these missing metrics. And it also doesn't mean that if we start pre-populating, this doesn't tip over the Prometheus server. But like you said, like 30,000 on 5 million would be very odd if that pushes it over the edge. Do we have saturation metrics to tell us if that one with 5 million is in trouble?
No, we should. And I just quickly now I looked at the defaults as well, and that's at 16 million.
1.6.
Oh, 1 point. My eyes are.
I think. So
Yeah. You're totally right. Yeah. Okay. So then it is the worst, but yeah, I mean, we should. What we can do is we can look at the Prometheus IO docs. I think they've got a pretty good operating. Somewhere in here, they've got a pretty good thing about it. So maybe we should put that as I mean, it is a saturation metric of a sort, and we should be monitoring as such, and then also getting it into Tamland, so we know how long we have with these Prometheuses.
Well, where do we feel the pain? Is it in Prometheus itself, or when we try to run queries across a lot of them?
Certainly the startup time is like the famous pain of Prometheus, because you've got to load the whatever files into memory, and that takes longer and longer and longer and longer. But then also I just think the memory usage, I don't actually have a very good idea of managing Prometheus, but I think there's memory, because it's got to keep certain things in memory as well. It might, the indexes to where other things are. I'm not actually totally sure about it. I think that's a really good takeaway. Is we should be doing more to kind of be tracking that.
We don't want our Prometheus stack to explode on us, because
yeah, totally,
that would probably happen at the wrong time.
Yeah, and it is one of those things where we'll probably just one day find out, oh, we need a new Prometheus today, and so that's the kind of thing where we shouldn't do that.
My non-favorite topic, zonal clusters. That might actually be a very natural fit for Prometheus.
So Craig and I spoke about that in our one-to-one earlier. Exactly that topic. Do you want to expand on it a little bit, Jakob?
Oh no, I was just thinking. Yeah, go ahead.
No, go ahead, Jakob.
Oh, so it might be a natural way to divide up the Prometheuses, to have one, if there's this natural division there anyway. But I have no idea how hard it is to deploy or maintain any of that, because I'm not an SRE and I'm also not a Prometheus expert.
So just to expand on the idea for others a little, what we're going to have is we're going to have a Redis. We're going to have a sidekick cluster per zone, or per Kubernetes cluster. so that we can kind of have lots, and then each one will have its own Redis instance so that we can effectively horizontally scale the Redis behind Sidekick. But then also what we could potentially do is have a Prometheus instance that just lives alongside, that's paired with that cluster and collects its metrics as part of that cluster. And then, you know, it becomes one of those things that we're just stamping out more of these
I think
configurations.
Yeah, I think one of the reasons to do this might be that we just saw that the GKE Prometheus has 5 million series, and we said that's probably because of pod churn. So, like the more of these, if it's mainly because of the pods, it might be nice to also just if that is a source of churn, and if we can separate them, that might be And we already know that the Prometheus architecture. Well, because we use Thanos, it's perfectly fine to have multiple Prometheuses. And this is why I say that zonal clusters are not my favorite topic, because I am a bit nervous about the application impact of having multiple Sidekicks, of having Sidekick talk to different Redises with the same Postgres. But that's a different topic. But I think in the case of Prometheus, I don't see a reason why it wouldn't work, because we already do this sort of stuff. And it's mainly about, like, operationally, is this something is this hard?
So one very minor or low risk issue at the moment is that for Sidekick, we don't evaluate the SLIs at the Thanos level. We still do it at a single Prometheus level. So, you know, we would get split brain SLI alerts. And that's not a problem, because all of the, well, almost all, except for the 7 that Craig mentioned, all of the jobs are being evaluated within one cluster, which is the regional Sidekick cluster, and they have and they're all in there, so they're all getting evaluated in one place. So it's not a problem. If we split it up like that, you know, jobs could run in one of 3 clusters, and we just have to do exactly like what we did with the rest of our SLIs and move them so that they're evaluated in Thanos at a higher level. And we've got, the reason I say it's low risk is because we've got all the tooling in place for that. You know, we've got the aggregation sets. We could probably just set up another aggregation set for that exact
right, but we currently have things in place that are only correct because certain data lives all on one Prometheus server.
Yeah, and all the Sidekick jobs for a certain class all go to the same Prometheus, so it's not a problem.
So I'm sorry, I cannot turn on camera right now. For my understanding, isn't the problem with having Sidekick on zonal clusters the fact that we take out a cluster at a time when we are upgrading, which would mean, right, like if we have separate Redis per zone, that would possibly cause additional problems. Like we would have to have a master of main Redis that would be able to like compensate for the fact that we are taking out zones at a time.
I think we were talking about Prometheus now.
Right.
Yeah.
I know that we were talking about Prometheus, but it feels like we're trying to resolve one problem to maybe potentially create another. That's why I'm asking.
I mean, I wasn't aware of that argument, and why would we take out the entire cluster while we're upgrading it?
There was, first of all, a challenge with net port allocation. If I remember correctly, we used to do it in one go. And then after we had that, we've realized it's actually a nice feature to be able to see any breakage prior to rolling out to the rest of the cluster. So we always have some capacity. That's all up for rediscussion, right? Like it's not we were purposeful there, but it's something to keep in mind when talking about these topics.
And how would that impact? Can you just explain in a bit more detail how that would impact Sidekick? Because I'm not following.
So if we are talking about, like, if I understand correctly what you were talking about here, like you were saying that we would have Redis setup per zonal cluster. My understanding is that if we take out the whole, zonal cluster, whatever was stored in the Redis instance that was for that specific zonal cluster could cause issues elsewhere, right?
Okay, but I never, I didn't expect that we would delete, you know, like we might take it out of, are we talking about actually deleting the cluster and recreating
No. Like taking it out of rotation, right? Like being unavailable, right?
Yeah, but that shouldn't affect Redis too. I mean, I can't imagine
the challenge
that would
here.
affect Redis
So the
too
challenge.
much.
So yeah, the challenge here I'm talking about is like the different versions that we would run. You know, depending on the cluster we are rolling out the new versions to, right? Like, if I remember correctly, one of the problems was that at any given point in time, one of these clusters could be running a different version of, well, GitLab, basically. So wouldn't that cause a problem?
No, I mean, that's already a thing, right? That's something we have to deal with already.
Right, but if you have a separate Redis cluster, you would, separate Redis per zone, that would mean that the new version, or that there would be a version stored differently in Redis. So you might actually end up having a situation where Sidekick pulls from Redis something that is in a different format.
We already have that.
Yeah.
We already have that?
Yeah.
Yeah, like a deploy is slow. So we have
That's true.
Jobs from submitted by old versions, picked up by new versions, and the other way around. And it's a horrible mess, but we already have it.
But that's a horrible mess that all big,
you
know, SaaS setups have.
If you can't do an atomic deploy, then you have this mess. Yeah.
Yeah. I'm just kind of curious. This sounds like something that people are talking about. Is there an issue, or has this been written down somewhere? Because
it has been written down somewhere in one of the many issues that we have. If you were to ask me now, I don't know. You might need to ask Jarv or Scalability where this was discussed.
Yeah, because I would push back on that. I mean, I you know, I don't necessarily agree with that, to be frank. There's yeah. I'll respond on the issue. I'll try to find it, or I'll ask Jarv about it, because I don't think that's it doesn't connect for me at the moment, at least.
I think I see a general problem here where there is a solution, which is this Redis per cluster Redis per Kubernetes cluster for Sidekick, and different problems that they think this solution solves, and then you get a disconnect where I think on the delivery sides, from what I've picked up from Jarv, there's this idea that you could have within a zone, you could have uniform, like you could drain an entire zone, upgrade GitLab, and put traffic back in, and then you no longer have this mess of different versions of GitLab talking to the same Redis, which is a different problem from scaling, having to process lots of Sidekick jobs, which I think is the problem Andrew is talking about. But both of these things have the potential solution of Sidekick zonal clusters. So I suspect this sort of confusion is going on here, and I think that whenever we talk about this, we should also be clear about what problem we're trying to solve, and not get attached to a solution. Like the one thing that always makes me a little anxious is if I see people getting very attached to a certain solution because they think it will solve their problem, and in the end you end up with something that doesn't solve any of the problems correctly, or something complicated that just doesn't solve your problem, but we all got very attached to a solution. So
this sounds like a perfect opportunity to actually pair with delivery on like a larger discussion. So maybe it's worth, like, first of all, starting up like a general issue to talk about the problems here, and then pairing with delivery to see whether we need to do some architectural changes to how we deploy GitLab, and what is else necessary to add to our infrastructure.
Yeah. I mean, I can see the advantages also of like totally shutting down traffic to a cluster, but there's also disadvantages to it as well, right? And so it makes me wonder whether making that decision will make other things kind of more difficult in future, and also whether that means that we'll miss problems that customers might have because customers aren't running, you know, multi Kubernetes clusters for, they don't have that luxury.
Right, but at this
for
point,
self-managed.
we also have to take care of what GitLab.com needs,
Yeah.
right? Like if we can't scale further, then there is not much to discuss there, right? So, yeah.
Yeah.
I just want to be clear that I don't think that we made any purposeful decision when it comes to how the clusters are organized, deployed to, and so on. It was more of an outcome of our migration. So it might be a good time to revisit this with delivery.
Yeah. Should we put something into their demo call?
Might be worth doing that, yes.
Cool.
Although their heads might explode because they have 3 different migrations currently in mind, but let's do it.
I was about to say maybe we should give them like after the release is out. I think they've got quite a lot going on, and if we do this before the release, I don't know if we'll have all of their focus on this particular topic. So maybe we give it a week or 2 before we put it in their agenda.
We can always do like the async write-up, like they describe the problem and start the discussion, right?
I'm trying to find this concern around the versioning and stuff, but I'm so far drawing a blank.
You should ping Java or Scalability for that one. I remember discussing this.
That Ernst created 3 years ago?
No, that's the namespace one. I don't think so.
Well, in the interest of time, I see that Marin's got another item on the agenda. So shall we hop to that one?
Yeah, if you don't mind, this is more of a question now that I see Craig is around. Like we see the recurrence of the cron worker not being able to archive the trace jobs again. So we are in danger of data loss, so to speak, again. Craig, you mentioned in that comment that this is a pure infrastructure problem, but I want to talk about whether that's actually the case. Yes, I know the fact that we have like a large sidekick pod churn, and like this is becoming a theme of this call a bit. But at the same time, I just kind of want to discuss whether the application is not able to do what it's supposed to do in this new environment. Maybe the architecture needs to change as well. So I just want to kind of open up that for discussion. And maybe you'll give a bit of a background to folks in the call.
Cool. So the very simplest, quickest summary I can give you. We have trace chunks get put into Redis up to 128K each. Those that get moved into object storage, and then when the job finishes, those objects get collated into a final artifact, which then gets put back into object storage. Some of our jobs have something in the order of 10,000 plus of these chunks. And the rate that we can get those out of object storage is order of 15 or 20 a second. So collating those in the end takes 10 plus minutes, give or take. I haven't got actual numbers, but that's sort of scale we're talking. And the auto scaling of sidekick workers in Kubernetes often doesn't let those complete. So the initial creation of the artifact fails, and then the cleanup job, which is trying to clean up all that and all the other ones that fail for various other reasons, also can't get past these big chunky ones, and they build up over time. And that's at least a big part of the okay case, not the things went really, really horribly wrong in the first place, problem that we have. So the app could be re-architected. I mean, if we could do more of those in parallel, I mean, the slowness with downloading the traces from object storage is that they're done serially. We do one after the other, and they take some number of milliseconds each. What's it, probably 50 to 100. And it's just that they're happening. It's not that object storage can't handle the throughput, it's that we're doing it in a single thread. So if we could bring those down multiple at once, we could reduce that by factors. 2 or 3 times would probably be enough. If we get those down to 2 or 3 minutes, we'd get a much better chance of those working. It's not wrong. The only other way would be to pre-collate them in smaller chunks, but then you're just throwing data around over and over again, and I'm not sure that would be. You'd just be fighting, putting together 10 of them and then putting them back into object storage, and then at the end putting chunks of them together. That seems a bit weird to me.
So I'd like to take like a page out of Andrew's book in this case, and maybe like discuss whether 10-minute job in Sidekick is something that we want our application to do, and maybe we can set a goal of what we can offer as infrastructure and ask development to tell us what they can do within that period of time and push back if that's not doable. So, like it feels to me like the long running or stable shard suggestion that you're making, it goes completely against the Kubernetes philosophy there, right? So like I would like to challenge the situation a bit if possible, and if not really possible without a major re-architect, we go back to I don't know. I don't want to go back to VMs, but the VM behavior.
Yeah,
I agree with having to be more resilient, but 10 minutes feels like a very small number for a pod to live, when none of them seem to live more than 10 minutes. I mean, we're just never getting. It's not like some of them die quickly. It's none of them seem to, or these jobs are ending up on pods that never survive.
That sounds wasteful if it takes almost a minute for the app to boot.
Mm.
Yeah.
But we already set the limit, like the maximum runtime for a job is already 5 minutes, isn't it?
No, that's for it. That's what we judge them on.
Yeah. So if we want the jobs to be, we want them to complete. But if something takes longer than that, like this is twice the time we're talking about.
I mean, well, security, the security report jobs can run for 60 minutes. And so, this isn't even the worst of it.
Imports and exports are the other side of it as well. I mean, that's the classic case, which is some of them are tiny and some of them are huge.
Yeah. And the problem, I mean, I agree with Maren, like we should start pushing towards saying, we can't scale things that if somebody does one push, we go off and do an hour's worth of compute on that. That's just not going to work. That doesn't scale. But at the same time, a lot of these things are what they are. And so we're going to have a lot of exceptions to that rule because they're not going to be able to change them super quickly. But maybe we should start turning the ship in that direction and start making noises that this is not acceptable.
And this seems like a decent one to start with as well, because we've had the problem in the past. We've done manual intervention on this for months now. We've been doing this manual intervention, and now we thought we'd gotten somewhere and we haven't. We're back to where we started. So this seems like a decent one to say, you have to have a better long-term plan for this. In the short term, we can do X, but we can only support that for a very short period of time. You need to show us that you're moving in a better direction to not have these jobs running for quite such a long time, because of the reason you said there. Like if you're doing this massive compute function for every single push, it's just not going to scale.
Right, but we started this with the CI trace chunk jobs, right?
Yep.
I had technical trouble, so I missed part of the explanation of what's going on. But is it a throughput problem? Like why does it even matter that these things get terminated after 10 minutes? They get scheduled once per hour and they expect to run for an hour and they only get 10 minutes?
Craig, you're muted.
Sorry. They're collating trace chunks out of object storage. Some of the jobs have 10,000 plus trace chunks. And if we do it serially, we only get 15 to 20 per second out of object storage. And it just takes that amount of time to get all the data down to be able to create the artifact to put back in, which we could do in parallel.
Is a single job processing the artifacts of a single job, is that taking more than 10 minutes and it's never completing?
Yeah. Sometimes, yes.
And that's why we have a build-up now.
Yeah. Some of them do make it past that, but it's easy for them to get caught by the looks of it.
Yeah.
So,
okay.
Related to the project export import, just want to kind of share how that whole thing is going on that side. So we have this, like you said, Craig, it's the same problem basically, right? Now, the challenge there is the feature itself is outdated architecturally, right? Like it needs a complete rework because it was already not reliable in VMs. So we are right now looking to create that stable shard that you're talking about with a couple of pods that will be running there almost exclusively just for project imports. But we already know that's not going to work. Like we already know this is going to fail. As soon as you have like more than 4 or 5 parallel long-running migrations, you start queuing and it just goes out of hand, right? And we don't have infinite capacity. So what is being done on the side, sorry, and just to finish the thought, what's being done on the side is we are buying time for the team that is responsible for project import-export to actually redo the feature. So this way we can support them for a tiny period of time while they get ahead, but everything else is stopped, right? Like we're not taking new project imports, like they're failing, it's known and so on. So it's a bit of a mess. I don't want us to get there with this situation. So that's why I would like to start these discussions in parallel, like Rachel mentioned, right? Like we need a longer term plan, and the stopgap, the total issue that you're asking for approval, that can only last for a bit. Like it can't go for forever, you know. Sorry,
I don't even want to do that work, but it's just like sort of faced with it.
Yeah, like I just want to kind of like also say where I understand why we're doing it, and I totally support why we're doing it, but we should do it with like as much pushback as possible, because every time we take something and run it on its own special snowflake, we're actually building the worst of all worlds. We're building VMs on top of Kubernetes, right? And we're getting all the administrative and operational overhead of running VMs on top of the operational administrative overhead of running on Kubernetes. And you know, the more we allow this, the more pain we kind of kicking down the road. Because, you know, there's no scaling on these things. There's, you know, everything we know that's wrong with it. We're basically just using Kubernetes as a deployment mechanism then.
So then did those items just get stuck as like P2 infradev issues until they get resolved? Is that the right way to provide the pushback and visibility on it?
Well, for this specific one, because it has the visibility in the SaaS stand-up, I can make it into not necessarily a rapid action. I don't think we need a rapid action for this, but we need an organized effort from multiple sides to get this thing done. So what I could do is, if you have a bit of a write-up of like what do we need to expect from development, what are we going to do in like as a stopgap and so on, I can go with that and explain like what kind of effort do we need, and maybe hopefully it doesn't turn into a rapid action, but more of a larger project that we need to collaborate with others on. And it could be, this is a scaling problem, right? So this is what we need to do as well. So we can pair with a team that is responsible for this to design a new, redesign this feature basically.
Maren, this does sound like engineering allocation if you wanted to do it through that.
Good point.
You know, and get you know, that's what most of that infradev meeting is about now. Okay. And you know, Christopher's doing a great job of driving that.
That makes sense. Let's thanks. I forgot about engineering allocation. I still don't know how to use it. I think that's actually a really good approach there. So theoretically, we as a team could take that on together with whoever is the engineers allocated there and drive it as one of the projects.
Which project are you talking about now? The importers or the trace chunks?
No, the trace chunks. Import is on the other side.
Okay, well,
sorry, Rachel, I didn't know this was part of InfraDev, the engineering allocation. I only got to that meeting this week.
Yeah, it's still new to me. I'm also still learning how to make it useful. But so what I'll do is I'll draft Craig's last comment on this one issue is about it being firmly with infrastructure. So I'm going to draft a reply to that. But I'll draft it and then send it back to Craig just to check that my statements are right. and then we'll try to push it forward as a project using that engineering allocation.
Cool.
Out of curiosity, what's an engineering allocation?
If we can stop the recording, I can say the real thing. Otherwise, it's a way to actually get some architectural changes done through outside of the regular scheduling that product does. So outside of the
it's part of InfraDev, and it's a different.
It's a different tool.
It's a different tool in the InfraDev toolbox to get certain
Correct.
things
So you
to
have
happen.
Andrew, you want to explain it?
No, my understanding is that the engineering department has got an allocation that they can use for longer term strategic initiatives to fix. So in my mind, InfraDev is quite tactical, and it's quite like, we need to fix this thing now, and we're going to scream a lot until it gets fixed. Engineering allocation is the next rung up, where there is a certain proportion of headcount that's dedicated to addressing kind of strategic problems. Like off the top of my head, like I would imagine, the object storage problems around file upload and all of that would be a great engineering allocation problem. It's not something that you can address really short term, like, in the next 3 releases. And it needs devoted kind of engineering, and Christopher's managed to get an allocation of headcount that can work on those projects, and it moves around between teams.
So
I
something
don't know if
that
that's
sits in
perfect,
between,
but that's my mind. Yeah.
it sits in between InfraDev and Rapid Actions. Like it's faster than InfraDev, but not as do it now as Rapid Actions.
No, it's slower than InfraDev. It's slower than InfraDev and slower than Rapid Actions. So it's the 3rd tier down.
It's a different optimization. It's an optimization to skip the whole prioritization process that goes through multiple milestones where you need to go through a product manager continuously. This is more of you have a dedicated set of people who can actually do the work and schedule the work themselves to skip a couple of levels, right?
Yeah.
And product puts aside some reserve in capacity for engineering to be able to do this.
And the kind of status updates of that is now in the Tuesday InfraDev. So InfraDev and engineering allocation happen together in that Tuesday evening meeting. And so the first part of the meeting, we talk about InfraDev issues, and then we talk about engineering allocation. And what you obviously find is there's a lot of overlap. So some of the stuff that's been raised is InfraDev. It's like, oh, well, actually, that's going to be this engineering allocation that's underway. Or the other thing that might happen is, we're seeing this common pattern over and over, like I'm going to use a file upload example again. We have all this different pain because of carrier wave, but it's not something that, one team is going to go, one stage group team is going to fix. So let's get an engineering allocation, and rather than having 10 stage group teams fixing their own individual carrier wave problems, we'll have an engineering allocation. We'll come up with something better, but it might take, 4 months.
So I have an item for tomorrow for the SaaS stand-up. So if anyone can let me know, like whether we'll have a tiny bit written up so I can actually share. Otherwise, I'll move the update for Monday and try to propose.
I'll write the draft today, and when Craig gets online tomorrow, then he can confirm that that's okay. So you will have an update for tomorrow.
Awesome. Perfect. Thank you.
Yay, time zones.
Yay. And Craig, also, I really appreciate the write-up you did in that issue. Right, like it was really super clear what is happening there. And I do appreciate your helpfulness to say that this is an infrastructure problem. But as someone who's been in infrastructure for a while, I realize it's very rarely only an infrastructure problem.
That's a fair call.
Well, we're at time. Thank you Thank you very much, everyone, for the great discussion today. We've gone everywhere from maths to process. So I hope you have a good rest of your day. Thanks so much.
Thanks. Bye.